All right, so in this section 1.2, we're going to review and talk about how to combine functions, how to transform functions, um, and things like that. So this will probably be, I would guess, 3 videos that we'll do for this chapter. So the first one, we're just going to talk about adding and subtracting, multiplying and dividing functions, which is pretty basic and pretty much the way you would think it would be. Um, if you add two functions, you're just going to add the functions and combine like terms. If you subtract, same thing, you subtract them and combine like terms. And then same thing with multiplication and division. Now with division, like you'll see in this example, a lot of times there's not really any way to simplify it. You're just literally putting one on top of the other, and then that's about it. Um, we may have questions about the domain, but we can talk about that if we see that. So let's look at this first example. So we have n of v equals square root of v, and then t of v is 3 minus v. So we're going to find equations and domains for these functions. A of v is just where we're going to multiply these, and then b of v, we're going to divide them. So a of v is n of v, which is square root of v times 3 minus v, and then we'll simplify that. So we have 3 square root v, and then minus, so v times square root v. If you remember from your exponent properties, you will add the exponent. So we have v to the 1/2 and v to the first. So add those exponents and we get v to the 3/2. And then now what's the domain? So really the only thing I have to consider here for the domain is what's the domain of the square root function. And both of these are technically square root functions. This would be v times square root v if we didn't simplify it, or the square root of v to the third. We could also write it like that. But in any case, both of these v cannot be negative. So the domain for this one is going to be 0 to infinity. Right. So what happens when we divide? So division is usually simple enough to set it up. So n of v is square root v, and t of v is 3 minus v, and there's nothing really you can do with that. So that is the answer. Now, how do we get the domain? So we have two different parts to this. The domain of the top is 0 to infinity because of the square root. If you remember, the domain of the bottom is anything that would not make the bottom be 0, would make the denominator be 0. So the only way that denominator is 0 is when v is 3. So our domain of the denominator is negative infinity to 3 union 3 to infinity. So now the domain of the function is any numbers that are in both of these intervals. So obviously we're only looking at positive numbers and 0. But then we have to take out 3 because that would make the denominator be 0. So the domain, we start at 0, and then we're going to have to take out 3. So we end up with 0 to 3, including the 0, not including the 3. And then we're going to add 3 to infinity, where we don't include either endpoint, never include infinity anyway. But that's how you do that. So look at the top, look at the bottom, and then the domain would be the intersection of those, or whatever numbers are in both of those intervals. So we're obviously not including any of these negative numbers because that would not work with the square root. And we cannot include 3 because that would not work with the denominator. All right, next one. So here we're going to subtract. So we have the annual revenue in millions of dollars is R of t equals 0.2 t squared plus 3t plus 5. We have that there. T is measured in years. Now, a lot of these you probably need to pay attention to what the variables are representing. Some of these, like part B, we're going to have to interpret this. And the interpretation is pretty easy as long as you know what the variables are standing for, typically. So t equals 0 corresponds to the year 2000. Annual cost is C of t equals 4t plus 9. So we have this. And so P of t, and this would be the profit, is revenue minus cost. So we're just going to subtract these two. And it's pretty basic algebra here. The only thing that could mess you up is messing up with the minus sign. So we have 0.2t squared. So combine our like terms, 3t minus 4t will give us a minus t. 5 minus 9 will give us a minus 4. So that is our profit function. And it does not ask for the domain, but the domain of any quadratic equation or quadratic function is all real numbers. So, all right, so we're going to compute and interpret P of 7. So P of 7, we're just going to plug in 7 for t and simplify it. So plug it into the calculator, and we should get negative 1.2. And if revenue is measured in millions and cost is measured in millions, profit is also going to be measured in millions. So whenever you're adding and subtracting functions, they really all need to be the same units. So what this means is after, or we could say in 2007, so T is 7, so T equals 7, and then P is negative 1.2 or negative $1.2 million. So if T is 7, T is the years after 2000. So the interpretation would be in 2007. The profit is negative $1.2 million. Okay. So there is that one. Now let's talk about composition of functions. And so given two functions f and g, the composition of f and g is defined by h of x equals f of g of x. And I'm sure you've seen this before in algebra classes. The composition means one function is the input into another function. So in this case, we have g of x, that is the input into the function f. And sometimes, I don't think this book uses this, but sometimes you'll see this with a little circle like that. It's also used for composition. I don't think I haven't seen that in this book so far, so we may not need that. All right, so the first example we have f of x equals x squared, g of x is x minus 3. H of x is the composition f composed with g. K of x is the opposite. We have g composed with f. And we want to find h of 5 and k of 5. So h of 5 is f of g of 5. So we're just plugging in the 5 for the x. And on these, we work from right to left. So we need to find g of 5. So g of 5, we'll put this down here. G of 5. We're going to plug the 5 into there. We have 5 minus 3, so g of 5 is 2. So we need f of g of 5. G of 5 is 2, so we need f of 2. And then now we're going to plug the 2 in to the x squared, so we get 2 squared. So h of 5 is 4. So you start, I want to say start in the middle, but it doesn't really look like the middle. Start at the right, plug in your x, and then work from right to left. And that will simplify down the answers. So now k of 5, we're going to do kind of the opposite. So this is g of f of 5. So now we're going to plug the 5 in to f. So f of 5, that would be 5 squared, and we get 25. So this means that g of f of 5 is g of 25. Now plug in the 25 into the g, and we get 25 minus 3, and that is 22. All right, so again, always start at the right, plug in your x, plug it into the next function that comes, and then get that answer and plug that number into the next function after that. All right, so we'll continue composition on the next.